Hello, fifth grade students. I'm Portia Harris, and I'm here today to talk to you about operations with fractions, which is topic 3 of your summer packet. This topic will cover the following standards: to add and subtract fractions with unlike denominators, including mixed numbers, by replacing given fractions with equivalent fractions in such a way as to produce an equivalent sum or difference of fractions with like denominators. The other standard it will cover is apply and extend previous understanding of multiplication to multiply a fraction by a whole number or a fraction by a fraction. The following vocabulary is going to be very important when you're adding and subtracting fractions with unlike denominators. The first two are no new vocabulary words. You learned these in 3rd grade. The first one is numerator. It's the number above the fraction bar in a fraction that tells you the number of equal parts being described. If you notice the 1 is highlighted, it shows the equal parts being described, which is the shaded parts, and is written above the fraction bar. The next vocabulary word is denominator. It's the number below the fraction bar in a fraction that tells the number of equal parts in a whole. If you notice the 3 is highlighted, and in the circle, it is broken into 3 equal parts, and they label it. So 3 tells me the equal parts in a whole, and is written below the fraction bar. The next vocabulary words that will be important is equivalent fractions and common denominator. Equivalent fractions is when 2 or more fractions that name the same part of a whole or the same point on a number line. Here's an example of equivalent fractions. The first one shows a fraction bar 2 pieces. One part is shaded. Here, this is actually 4 equal parts, 2 shaded, so I know that 1/2 is the same thing as 2/4. And then the last one shows 8 equal pieces with 4 shaded. This also represents 4/8, or it's the same as 2/4, which is equal to 1/2. The next vocabulary word is common denominator. It's a number that is a common multiple of the denominators of 2 or more fractions. So here I have 2/3 and 3/4. If I notice, 3 and 4 are different denominators. But when I skip count by 3s, 3, 6, 9, 12, and I skip count by 4, 4, 8, 12, 12 is the first common denominator that both of these share. Now, how I found that is skip counting, and that's called finding a common multiple is when I'm skip counting. Now, 2 numbers will have more than one common multiple, but you will want to work with the least common multiple. Now, getting into adding and subtracting fractions with unlike denominators. My first problem is 1/2 plus 2/5. I first want to find my common denominator by finding, again, the least common denominator using multiples, that's skip counting. So I will skip count 2, 4, 6, 8, 10, 12, 14, and so on. And then underneath it, I will do my multiples of 5. 5, 10, 15, 20, 25. Well, I see the smallest multiple they have in common is 10. So 10 will be our common denominator. Next, I want to make the fractions equivalent. Since I know 10 is my common denominator, I'm going to multiply 1/2 by 5/5. So I say 1 times 5 is 5, 2 times 5 is 10. And then I'm going to take 2/5, and I know 5 times 2 is 10, and I'm going to multiply the numerator and denominator by 2. So 2 times 2 is 4, 5 times 2 is 10. So I know 1/2 is equivalent to 5/10, and 2/5 is equivalent to 4/10. Then I add those two together. I take 5/10 plus 4/10, and I add my numerators going across. 5 plus 4 is 9, and my denominator stays the same because there will be 10 equal parts in one whole, so that number stays the same. Now, here's another problem with adding and subtracting fractions. Jenna spends 1 2/3 hours mowing the backyard. After taking a break, she spends 3/4 hour mowing the front yard. How much time did she spend mowing the whole yard? So I know this is combining both of those fractions together, which means I'm going to add those two together because it wants to know the total time for the back and front yard it took her to mow both of those together. So first I'm going to find my common multiples between the denominators 3 and 4. So I skip count. 3, 6, 9, 12, 4, 8, 12. I see that 3 and 4 have the least common multiple of 12 in common. So that's going to be my common denominator. So I'm going to use a model of squares this time. This represents one whole. This represents 2/3 because this whole is broken into 3 pieces and 2 are shaded. So this represents the time she spent on the backyard. Plus, we have the other model, the square, same size, same shape as these other squares. It has 4 equal pieces and 3 are shaded. This represents 3/4 hours. Well, I know that my common denominator is 12, so I have to take both of these squares and I have to make them into 12 equal pieces. I don't have to do the whole since that's already shaded all the way in. So then I use these dashes and I do 1, 2, 3. I do 3 dashes. That gives me now 4 rows and it gives me 12 total pieces in this first model. So now I have 1 and 2/3 hours is equivalent to 1 and 8/12 hours because there are 8 pieces shaded out of a total of 12. Plus, I do 2 dash lines to divide it into 12 equal parts. So now on this side, I have 9 pieces shaded blue out of 12 total pieces in all. So I know 3/4 is equivalent to 9/12. So when I add 1 and 8/12 plus 9/12, that gives me 1 and 17/12. Well, I know 17, my numerator is bigger than my denominator because 12/12 equals 1 whole. So if I say 17 minus 12, that will leave 5 left over and that will give me another whole to add. So 1 and 17/12 is also equal to 2 and 5/12. My next problem, it says chapter 1 of Henry's book is 5 2/3 pages long. Chapter 2 is 8 2/5 pages long. How much longer is chapter 2 than chapter 1? Well, it's asking me to compare 2 chapters, so therefore I'm going to subtract in this problem. The first thing I do is have to find a common multiple. I notice that my denominators are 3 and 5. So I skip count. 3, 6, 9, 12, 15. 5, 10, 15. Well, 15 is my least common multiple between the two, so my common denominator is going to be 15. So here, I can say 5 2/3. I can change that to have a common denominator of 15 by taking my whole number and separating it from my fraction. So here I have 5 plus, and then I take 2/3 and I multiply it by 5. 2 times 5 is 10. 3 times 5 is 15. I know that I multiply both of these by 5 because it takes 3 times 5 to equal 15. So whatever I multiply my denominator by, I have to multiply my numerator by. And also up here, if I'm not sure, I can say 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. The next thing I do is I change my next fraction, 8 2/5, and I separate the whole number from the fraction. So I have 8 plus, then I have 2/5. I know that 5 times 3 is 15 because up here when I was finding my common multiple, I said 5 times 1 is 5, 5 times 2 is 10, 5 times 2 is 3. Whatever I multiply my denominator by, I have to multiply my numerator by. So 2 times 3 is 6, 5 times 3 is 15. So 8 2/5 is equivalent to 8 6/15. Now up here it says, how much longer is chapter 2 than chapter 1? Well, chapter 2, I have 8 6/15. But I know I can subtract my whole numbers, 8 minus 5, that would be 3, but I can't say 6 minus 12. So I'm going to have to regroup here with my mixed number. So I know that 15/15 is 1 whole. So I took 1 from this whole number, and that's now a 7, plus 15/15. This is a total of 8, plus the fraction of 6/15. So now, since I regrouped, it's 7 and 21/15, because 15 plus 6 is 21. So now I can finally subtract. 7 and 21/15 minus 5 and 10/15 is equal to 2 and 11/15. So chapter 2 is 2 and 11/15 pages longer than chapter 1. Okay, with this problem I have, what is 1 and 1/2 plus 1 and 2/3? I have my common multiples of 2, 4, 6, 3, 6. So when I skip count by 2 and 3, I see my least common multiple is 6. So my common denominator is going to be 6. So I'm going to use my models again. This represents 1 and 1/2. This represents 1 and 2/3. And again, I'm going to take those models and I'm going to divide them to make my common denominator of 6. So since this is 2 pieces, I had to draw 2 lines going across to make 6 equal pieces. Now this is equal to 1 and 3 out of 6 pieces shaded. And I had to take this, which had 3 pieces, and cut it in half to make 6 total pieces. And now I have 1 and 4/6 pieces shaded. So I have 1 and 3/6 plus 1 and 4/6 is equivalent to, I have 2 wholes, because 1 plus 1 is 2, and 3 plus 4, when I add my numerators across, is 7. Remember, my denominator doesn't change because it doesn't change that there are 6 pieces in 1 whole. So 1 and 3/6 plus 1 and 4/6 is equal to 2 and 7/6. Now I notice my numerator is bigger than my denominator. So I can take a whole out of there. And remember, 6/6 is equal to a whole. So when I say 7/6 minus 6/6, that gives me 1/6 left over. And now I have a total of 3 wholes and 1/6. But I will take both solutions. You can either say 2 and 7/6, or you can say 3 and 1/6 if you simplify it. Now the next one, I'm using a number line. Michael rode his bike 2 and 2/3 miles on Saturday. He rode another 1 and 5/6 miles on Sunday. How many miles did Michael ride his bike on both days combined? So it wants me to add because it wants me to put both of those days together. Again, I have to find my common multiples. 3 here, 6 is my denominator here. 3, 6. Oh, I noticed that when I skip count by 3s, I land on 6. So 6 will be my common denominator. So I only have to change 1 fraction this time. So here's my number line laid out. Since he rode 2 and 2/3 on Saturday, I'm going to start with the whole number 2 on my open number line. And I just put the numbers 2, 3, 4, 5. Now, since my common denominator is 6, I'm going to put 5 tick marks in between each whole number to get 6 equal parts. So when I do my hops, I have 6 parts. 1, 2, 3, 4, 5, 6. So in between each whole number, there are 6 equal parts, which means this will be 2 and 1/6, 2 and 2/6, 2 and 3/6, 2 and 4/6, or 2 and 2/3, 2 and 5/6, 3 wholes. And it will repeat, and I will just change the whole number. 3 and 1/6, 3 and 2/6, 3 and 3/6, 3 and 4/6, 3 and 5/6, 4 wholes, and then it repeats. So now that I have my number line laid out, and I've marked 2 and 2/3 on the number line, because I know that 2/3 is equivalent to 4/6, because 2 times 2 is 4, 3 times 2 is 6, so 2 and 2/3 is equivalent to 4/6, so that's 4 hops is equivalent to 2/3. Now I can add 1 and 5/6. So I do one big jump of 1 whole on my number line. I go from 1 and 2/3 all the way to 3 2/3. And then I hop by 1/6 5 times. So then I have 1/6, 1/6, 1/6, 1/6, 1/6, and I end up landing on 4 3/6, or I can say 4 1/2. So here's what my equation looks like. 2 2/4, 2 4/6 was it. Here's what my equation looks like. 2 4/6, which is equivalent to 2 2/3, plus 1 5/6 is equal to 3 wholes, because 2 plus 1 is 3, and then 4 plus 5 is 9. And remember, my denominator does not change 6. So I have 3 9/6. Well, notice again, my numerator is bigger than my denominator. And if I take 6/6 away from that, which is a whole, that leaves me 3/6, and I add the whole to the whole number. So that is equivalent to 4 3/6. So I will take 4 3/6, and some of us recognize that 3 is half of 6, so that is the same as 4 1/2 miles. Now we're going to move on to multiplying fractions, which is another operation. The common vocabulary we have here is not new. It's area, the amount of space inside a closed two-dimensional figure. So that's the same thing as multiplying length times width. And since I measure in squares, that's why it's called square units. The other vocabulary is product. It's the result or the answer to a multiplication problem, and that is your answer. The next vocabulary is factors. Those are the numbers you multiply together in a multiplication sentence. And then the last vocabulary is unit fraction. It's a fraction with the numerator always of 1. And because it represents one piece of the whole. So 1/2 is your unit fraction. 1/3 is a unit fraction. 1/8 is a unit fraction. Any fraction with the numerator of 1 is a unit fraction. So getting into our first problem, Titus has a square sheet of paper measuring 1 foot on each side. He folds the paper in half vertically, then he folds it into fourths horizontally. Titus unfolds the paper as shown below. What is the area of each part? My key here is that vertical means going up and down, horizontal is going across. And it's asking me for each part. Each means one piece. So here it shows that he folded it in half, and I have 1/2 on this side and 1/2 on this side. And then when I look going across, he has 4 rows. So now each section is one piece out of 8 total pieces in all. So the area of each part is 1/8, because it's 1/8 out of the whole. Let's look at another example. Rachel is designing a newspaper ad. The ad will include a piece of art whose dimensions is 5/8 inch long and 1/2 inch wide. How many square inches of space will the art cover? Here I take the fractions. 5/8. First I draw a whole, because both fractions are less than a whole, and I divide it going down into 8 equal parts. And then I shade 5 of the 8 parts. Now, if you're doing this, you might want to use colored pencils. And the key is so that you can see 2 different colors, because you shade the 5 going top to bottom. And then I take that same picture and I cut a line going across, so I have 2 rows to represent 2 as the denominator in this fraction. So 1 row, 2 rows. And since my numerator is 1, I shade 1 whole row going all the way across in a different color. Now your answer is going to be the overlapping pieces. That's going to be your numerator. How many do I have overlapping here? 1, 2, 3, 4, 5. And then I have to count for my denominator, the total pieces in a whole. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I wrote this as an equation. It will be 5/8 times 1/2 which I multiply my numerators together. 5 times 1 is 5. And then I multiply my denominators together. 8 times 2 is equal to 16. So my answer is 5/16 is the square inches of space that the art will cover. Our next problem, what is 3/4 times 1/3? If you remember, your multiplication symbol can be replaced with the word of. Now in this problem, we're going to use a number line. Since it's 3/4 of 1/3, I'm going to take a number line, I'm going to divide it into 3 pieces. I start at 0 and I label it with 1. So between 0 and 1, that is 1 whole. Both of these fractions are less than 1. And this happens to be a unit fraction because my numerator is 1. So I'm going to say between 0 and 1, I'm going to draw 2 tick marks in between to make 3 equal parts, because this is 1, 2, 3 pieces. So the first line is 1/3, 2/3, 1 whole is the same thing as 3/3. The next thing I'm going to do is each third is going to be divided into fourths because my other denominator is 4. So I'm going to say 1, 2, 3, 4. So I draw 3 tick marks in between this third to make 4 pieces. Then I draw 3 more tick marks in between these thirds to make 4 pieces. And then I'm going to draw 3 more tick marks between these thirds to make 4 pieces. I know that between 0 and 1, there are now 12 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So each hop is 1/12. So it means each piece is 1/12. To continue this problem on, to finish it out, I have to say 3/4 of 1/3 is shaded. So I shade 3/4. This is a fourth, this is a fourth, and this is a fourth. 3 out of the 4 pieces in 1/3 are shaded. Because remember, I took each third and I divided it into 4 pieces. So I'm shading 3 out of the 4 pieces in that third because it's 3/4 of the 1/3 piece. So the whole is divided into 12ths. So with 3/12 shaded, because this is 1/12, 2/12, and 3/12. I know that's kind of confusing, but I have to think of it as 3/4 of 1/3. So this is 3 out of the 4 pieces shaded of the 1/3 piece. But when I look at where it lands on my number line, it actually lands at 3/12. So what I want you to do is I'm going to challenge you. Think about real world examples where you add, subtract, and you multiply your fractions. I'm going to give us a couple hints. When you're combining measurements given in fractions of a pound, like when you're at the grocery store, or you're combining quantities of time given in fractions of an hour, I might say, it takes me 3/4 of an hour to do laundry. It takes me 1/2 hour to cook. How long do I spend on my chores for the day? Also, when you're combining distances given in fractions of a mile. So talk to your family members about ways you combine fractions on a daily basis. I hope you enjoyed this video, and if you need to go back and review for your summer packet, please do that, and have a great summer.